So since yesterday I posted a video that was meant to be a combination of a whiteboard lecture and a MyOpenMath screenshot lecture, and I had some problems, I'm re-recording it, the part with MyOpenMath. So let's work through a good number of these problems. We'll start with question number 1. This is a SOHCAHTOA problem. The first thing I would recommend that you do is just go ahead and take the information that you're given and label your diagram. So we are told that A is equal to 5 and B is equal to 9. And then we use the Pythagorean theorem to figure out what C is. So A squared plus B squared is equal to C squared. So that's 81, and 25 is 106. So we're looking at the square root of 106. So for each of these, sine, cosine, and tangent, remember we're using SOHCAHTOA. So tells us that sine is equal to the opposite over the hypotenuse. So that means that the sine of A is equal to the opposite. Here is angle A right here. So opposite angle A would be this side right here. And notice that the adjacent side is the side next to angle A. The hypotenuse is also adjacent, of course, but the hypotenuse will never be labeled adjacent, it will be labeled hypotenuse. So since the sine of A is opposite over hypotenuse, that gives us 5 over the square root of 106. And then we need to rationalize the denominator. So then this will simplify to 5 square root 106 all over, ooh, that's fun, 106. And similarly, cosine is going to be adjacent over hypotenuse. That's the ca. So ca. So that means that cosine of A is equal to adjacent over hypotenuse. And then we rationalize the denominator. Tangent is TOA. So tangent of A TOA means opposite over adjacent. Opposite A is 5. Adjacent is 9. And there you go. To get each of the reciprocal functions, secant is the reciprocal of cosine. So to get the secant, we take the cosine and flip it over. Flip it over right here. You don't want to wait till the end. So that means that the secant of A is going to be the reciprocal of this number right here, square root of 106 divided by 9. And you can get cosecant by flipping over this number right here, and get cotangent by flipping over this number right here. Okay, so now let's check to see what the answers are to make sure we got this right. 5 root 106 over 106, 9 root 106 over 106, tangent 5 over 9, secant root 106 over 9, cosecant root 106 over 5, and cotangent 9 over 5. So that's question number 1. Okay, so let's hop down now to question number 4. Questions 2 and 3 are cotangent questions, so they don't have videos, so I guess I can go through those really quickly. Okay, so all you have to do is find the complement of the angle. So 70, the complement of 70 is 20. Since sine and cosine are cofunctions, this would be the cosine of 20. See, there's 20. Cosine and sine are cofunctions, so you just need to find the complement of 71, which would be 19. Tangent and cotangent are cofunctions, so you just need to find the complement of 78, which is 12. Down here, we're going to say the same thing. The angle that goes here, theta, has to be the complement of 11, so that would make it 79 degrees. All right, now down to question number 4. To do question number 4, we're going to want to have our reference triangle. So let me start with the reference triangle. The 30, 60, 90 degree reference triangle. The 30 degree angle is the smallest angle in your 30, 60, 90 triangle, and therefore it's opposite the smallest side. The 60 degree angle is your medium size angle, so it is opposite the medium side. And the right angle is the largest angle, so it is opposite the longest side. We're looking at the sine, cosine, tangent, cosecant, secant, and cotangent of 30 degrees. So, in relationship, whoops, that was not supposed to happen. Okay, I have to redraw it. Okay, so I paused the video and redrew that. Now, in relationship to this 30 degree angle right here, this side right here is the adjacent side. And this side down here is the opposite side. And this side right here is the hypotenuse. So now to get each of these values, all you have to do is look for sine is opposite over hypotenuse. So that would be 1 over 2. Cosine is adjacent over hypotenuse, so that is the square root of 3 over 2. Tangent is opposite over adjacent, so that's 1 over the square root of 3, and 1 over the square root of 3 will rationalize to root 3 over 3. But let me make this note right here. We had that the tangent of 30 degrees was 1 over root 3. And then I rationalize the denominator to turn that into root 3 over 3. Now, the tangent is the reciprocal of cotangent, so if you flip over 1 over root 3, you have a plain old root 3. Flipping over 1/2 for cosecant, we have 2. And if you take the reciprocal of root 3 over 2, you end up with 2 root 3 over 3. Okay, so that's those ones. Now I need to erase this to scroll down. We can see these answers here too. Notice these are, oh, they did not rationalize the denominators there. You do need to rationalize the denominators in general. Now, if MyOpenMath doesn't not count you wrong, then lucky you. That's fun. Okay. I'm working from home today, so I apologize for the singing kid and parakeets in the background. Next, we have a 45-degree angle. So let me draw the 45, 45, 90 triangle real quick. So to get each of the values for question 5, you will use this triangle right here and simply do the same steps as you did for question number 4 with SOHCAHTOA. So I will just do the first part here for you. So the sine of 45 degrees, first you want to acknowledge that, well, you can use either one of these 45 degrees, it doesn't matter. If you pick that one, for example, then we have the opposite side right here, and we have the adjacent side right here. It doesn't matter which 45-degree angle you use. Opposite over adjacent, that would be TOA, is going to be 1, and that's easy. Cosine and sine. Cosine is adjacent over hypotenuse, and sine is opposite over hypotenuse, and both of these would be a 1 over square root of 2. So the cosine and the sine at 45 degrees are going to be the same thing, which should not be surprising because sine and cosine are cofunctions, right? So of course you should expect then that the sine of 45 degrees must equal the cosine of 45 degrees because 45 and 45 are complements of each other. Complementary angles, the cofunctions are equal there. Okay, now question 6 is done the same way question 4 is done, except pick the 60-degree angle instead of the 30-degree angle. And now we're moving on to the topic of reference angles. So let's work through each of these. I'm going to need a little space, so I will use the space up here. So what is a reference angle? Well, first let's go ahead and draw this angle, 217 degrees. I'll start with drawing an axes here. I'll do this 3 times, 1 for each angle. Okay, so my first angle is going to be, here's the initial side. Okay, that's right there. 217 degrees. So here's 90 degrees, 180, and 217 would be down here somewhere. So this angle right here is 217 degrees. I'll go ahead and draw all 3 angles real quick and come back to you. Okay, so here are my 3 angles drawn in standard position. The purple ones are positive angles, so they are going counterclockwise. The orange one is a negative angle, so it is going clockwise. To find the reference angle, what you're going to do is you're going to pick any point on the terminal side, and from that point drop a perpendicular to the x-axis. Now let me say this, it's very important, red flag worthy. Here's my red flag. We are going to only ever drop the perpendicular to the x-axis. If you drop a perpendicular to the y-axis, you will not be getting the correct answer. So only ever drop your perpendicular to the x-axis. So the reference angle, let me call the reference angle theta. Theta is the angle between the terminal side and the x-axis. It's the angle of this right triangle with the vertex at the origin. Okay, I'll call this one alpha, and I'll call this one beta. So alpha is this one right here, and beta is this one right here. It's this little angle right here. So this little angle right here, this little angle right here. So how do we figure out what the reference angle is? The best thing you can do is to draw a picture and then use some intuition. There's not a formula for finding reference angle. Okay, so what we're going to do is we're going to say this. From here to here is 180 degrees. Okay, if a semicircle is 180 degrees, then this chunk here that's left, theta, would have to be 217 minus 180. That's what this little chunk is that's left, okay, that little part. And so that is 37 degrees. In this case, alpha is going to be just shy of completing a full circle, right? So if this whole circle is 360 degrees, then to figure out what alpha is, I should say that this was theta. To figure out what alpha is going to be taking 360 degrees and subtracting from it the 346 that has already been used. So in this case, alpha is just 14 degrees. And in this case, we have beta. Beta is just shy of reaching 180 degrees. So beta is going to be take 180 degrees and subtract 157. So that is 13 degrees. No, that's 23 degrees. So notice sometimes you subtract 180, sometimes you subtract from 180, sometimes you subtract from 360. So there's not a formula. Instead, you want to draw the picture and see a visual representation and then use your intuition about semicircles and circles. Okay. Here are those answers, 37, 14, and 23. So, what do we do about finding the sine, the cosine, and tangent of 150 degrees? This is where you use the reference triangle. So now we're combining reference triangles with 30, 60, 90 triangles. Reference angles. So we'll start with the reference angle. The best way to do this is to draw a picture. Start by drawing a picture. So you want to start with your axis. Okay, that's a really bad axis. I'm going to erase it and try again. Better. So where is 150 degrees? Here's the initial side. Go 90. This is 180, so we want to go 30 shy of that. So start by drawing your angle in standard position. There's 150 degrees. Next, take your terminal side, and from the terminal side, pick a point anywhere on the terminal side, and drop a perpendicular to the x-axis. At this point, you should be able to see then that we have a 30-degree angle here. Now, you can use the 30-degree angle to figure out all of these values. Just keep in mind this. Since we're in quadrant 2, sine will be a positive value. But cosine, since it is a negative x value coming this way, will be a negative value. And since tangent is sine divided by cosine, tangent will also be a negative value. So whatever your answers are, you're going to have to make sure that they are positive, negative, and negative. You figure out the signs based on the quadrant. Now, one thing you could do is you could take this triangle right here and label it using positives and negatives. So if you go from the origin back to this point right here, this side right here is opposite the 60-degree angle. Therefore, the length of this side is the square root of 3. But because I'm going backwards, I could label that negative root 3. So if you label your triangle with positives and negatives based off going to the right or left, up or down, that will also ensure that you get the correct signs. From here to here, I'm going up, and I'm opposite the 30-degree angle, so I'm going to label this one 1. And then this would be a 2. So now you can do the sine of 150 as take the 30-degree angle, your reference angle, and do opposite over hypotenuse, and you get 1/2. For cosine, you have adjacent over hypotenuse, so that's negative root 3 over 2. And for tangent, you have opposite over adjacent, which you rationalize that denominator, you get root 3 over 3. Okay, so let's look at the real answers here. In this problem, they did rationalize the denominator like I did. It just depends on the code as to whether it's showing rationalized or not rationalized. You will never get penalized, though, for rationalizing your denominator, okay? So, question 9. Now, this one combines coterminal angles, reference angles, and your 45-45-90 triangle, all in one problem. That's fun. So, first of all, what you want to do is you want to rewrite these in terms of their coterminal angles. So, I'm going to rewrite each of these. If you take 585, and from 585 you subtract 360. Then you get 225. So what I'm really going to do is I'm going to figure out what the sine of 225 is. These parentheses right here don't do anything, so you don't have to have them. You would have to have them if there was a negative number in here. So if you have a negative number, always include the parentheses. But with a positive angle, you do not need to. So then I also am going to find the cosine of 225. And then I'm also going to find the tangent of 225. And then you proceed with this question now as though you were doing number 8. So I will get this started for you. Let me start by drawing the triangle. Okay, so sorry I erased what I had here, but this said sine of 225, cosine of 225, and tangent of 225. And here is my 225-degree angle. And then from this, I am going to take a perpendicular to the x-axis, leaving me with this angle right here, which I'll call theta. and theta is my reference angle. So that angle is a 45-degree angle. So that means that I am looking at a 45, 45, 90 triangle when I am setting up this diagram. So what you could do is you could label the sides with negative numbers. This is going back. Oh, I'm doing this backwards according to what I normally would do. Okay, you can do it this way, but this is not going to be helpful. Let's just cross this out real quick. Okay, this is supposed to be -1. You're going down -1. And then right here, you have the square root of 2. So the radius of the circle is going to come from the terminal side. Eventually you're going to have a circle that goes around here. And this will always be a positive number. So this is -1, this is -1 because I'm going back and then I'm going down. But this hypotenuse will always be a positive number. So now when I'm looking for the sign, I'm looking for opposite over hypotenuse. And so that's going to give me a -1 over the square root of 2, which will rationalize to -√2 over 2. Okay, something happened there. -√2 over 2. Okay, so here are your answers. If you divide sine by cosine, they're equal, so you get 1. Okay, so now this brings us to some problems in the book that are kind of tricky, and that is solving the equations between 0 and 360. So the first step to being able to solve those equations is to know where on this circle you have a sine value of 1. So the best thing for you to do is to go and look at a unit circle. I recommend just Google search a unit circle. Let me do that right now. Unit circle. Let's get a nice image up. How about this one? Okay, so you can ignore these outer markings. These are radians. Just look here. We have 0 degrees, 30 degrees, 45, 60, 90. Here are all your special angles between 0 and 360. These are the angles that correspond to a 30, 60, 90 triangle or a 45, 45, 90 triangle. So for each of these, if you had a radius of 1, you could put points here for the coordinates. So let's go down here to where we can see the coordinates. Here they are. Okay, so if you have a radius of 1 on your circle, then this point here would be 1, 0. This point here is 0, 1, -1, 0, and 0, -1. We talked about that in an earlier lecture, the last lecture. As for these other points, the other points on the circle are all derived from 30, 60, 90 and 45, 45, 90 ratios. Some of these ratios should already look familiar. But the x-coordinate represents the distance on the x-axis, right? So if you go from the center over and then draw a line straight up, you have now formed a 30, 60, 90 triangle. This is a 30-degree angle right here. Okay, and the distance from here to here is represented by the x-coordinate, √3. divided by 2. And the distance from here to here is represented by the y-coordinate, 1/2. And the hypotenuse is the same as the radius of the circle. And the hypotenuse then is 1, because the radius of this circle is 1. It is called the unit circle, unit meaning 1, like uno. Unit circle, because it has a radius of 1. That means that every hypotenuse that you could draw in this circle will have a length of 1. So if you're looking at sine and cosine, remember that both sine and cosine have hypotenuse in the denominator, right? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So if you have hypotenuse in your denominator and your hypotenuse is 1, that means that you have 1 in the denominator. That means that the cosine of a given angle in this circle will just be adjacent over hypotenuse, and the hypotenuse is 1. So you have adjacent over 1. What is the adjacent side of any of these triangles? The adjacent side is always the x-coordinate. So cosine is equal to x. What about sine? If sine is opposite over hypotenuse, and the hypotenuse is 1, that means that you have opposite over 1. But in every single case, the opposite side is the y-coordinate. So for each of these coordinates actually give you cosine and sine values for every single angle. So let's go back to 150 degrees. Remember, we had a problem earlier on 150 degrees. If you're looking for the cosine of 150 degrees, all you have to do is look at the x value, because cosine is equal to x. So the cosine of 150 degrees is -√3 over 2. And the sine of 150 degrees is the y-coordinate. The sine is 1/2. That's how the unit circle works. It basically says, okay, once you learn your 30-60-90s and 45-45-90s and you know how to set up those ratios, good, then you understand where the unit circle comes from. But the unit circle is a way of organizing all that information so that you could memorize the sine and cosine. When I was in high school, I had to go into my trig class every day, and for the first number of weeks, we were quizzed every single class day on the unit circle. He gave us a blank unit circle. We had 2 minutes to fill in the entire thing. So it was like the equivalent of 3rd grade multiplication times tables. You memorize it. And it's actually not so hard to memorize, and I'll talk about that in the next lecture or the lecture after that. But that's how you use the unit circle. So now let's go back to MyOpenMath. Where is the sine of theta equal to 1? That's the same thing as saying, where is y equal to 1? Now remember, on the unit circle has 1s and 0s on it. They're located at the axes. This point right here is the point 0, 1. So the y-coordinate is 1 right here. Okay? Now let's say you had a different version of this same question. Let's say that they ask you to figure out where sine of theta is equal to, all right, come on. It looks like E theta. There we go. Negative root 3 over 2. Okay, so let's say this is the equation instead. Well, on the unit circle, there was a point here, and there was a point here that had x and y coordinates where the, in this case, the x coordinate was 1/2, and the y coordinate was negative root 3. That's supposed to be, oh, that's lovely. Let's try this again. Negative root 3 over 2. Okay, so this point right here was 1/2 comma negative root 3 over 2, and then this point right here was negative 1/2 negative root 3 over 2. This angle right here corresponds to 240 degrees, and this one right here corresponds to 300 degrees. So we had 240 degrees and 300 degrees. You don't actually have to know what the degrees are to answer this question, though. One of the answers was here, and one of the answers was here. So when you're plotting the points, you don't have to know the degrees, but if you're solving the equations, then what you'd end up with is that theta is equal to 240. Oh, wow. Okay, so if you were solving this equation like you were solving the equation in the book, then theta would equal 240 degrees and theta would equal 300 degrees. Or the solution set, usually you would say or, that either 240 degrees or 300 degrees is a possible answer because either one of them will satisfy this equation. For MyOpenMath, you don't have to solve the equation. You just have to plot the point on the circle. The answer is going to simply be either 1 dot, as in the case of a problem like this, sine theta is equal to 1, or 2 dots, as in the case of a problem like this. But for the textbook, you would have to take that a step further and give what the degrees are that correspond to the dots on your circle. So for the blue one, this dot right here corresponds to a 90-degree angle. Whereas for the purple one, this dot right here corresponds to 240 degrees, and this dot corresponds to 300 degrees. So you can do all this using 30, 60, 90, and 45, 45, 90 triangles, but it's a lot of work. The faster thing would be to go Google search a unit circle, because pretty soon you will be using the unit circle a lot, and it's going to become your best friend. So you might as well get used to it now if you can. Okay, so this brings us next to cotangent. Where is cotangent equal to negative root 3? This is a tricky question. Even if you have a unit circle, none of the cotangent values are there. So, how do you figure it out? Well, what you can do is you can take the ratio, the quotient identity, that the cotangent of theta, so you use the unit circle ratio here, the quotient identity, that the cotangent of theta is equal to the cosine divided by sine. Now remember that cosine corresponds to x. and sine corresponds to y. So all you have to do is look at each of your x-y coordinate pairs and figure out which pair, if you took the x and divided it by y, would give you negative root 3. And that's going to happen when x is going to be root 3 over 2 or negative root 3 over 2, depending on what you're dividing by. So if you have a positive root 3 over 2, and you divide that positive root 3 over 2 by a negative 1/2, that's this point right here. If you start with a negative root 3 over 2, and you divide negative root 3 over 2 by positive 1/2, you have this dot right here. Both of those ratios are negative root 3. The next question is a calculator question. I talk about this in the other lecture. To do a problem like this, convert DMS to decimal form, and then you can type it into your calculator. Okay, so I'm sorry again I couldn't get this in the lecture yesterday. We're still trying to figure out tech issues here, all of us, for class. So hopefully my next lecture will be a more perfect blend between online demonstration and Blackboard demonstration. And if you have questions, please let me know.